All right, folks. So we're looking at, to this point, we've done, or you have seen something called linear quadratic systems. Okay. Now we're going to kind of be moving into what we call 3x3 systems. And a 3x3 system, and it's really truthfully 3x3 linear systems. So let me kind of clarify that just a little bit. I just realized I didn't write that down here a minute ago. So 3x3 linear systems. Okay. So the nice thing is that when we do these, similar to the linear quadratic systems where we're looking for the points of intersections, we're still looking for points of intersections on these. The difference is this: we are no longer dealing in just two-dimensional space. We're dealing in three-dimensional space now, okay? And because we're dealing in three-dimensional space, what you're going to start seeing, or what you'll see, is the fact that you have this z variable start popping up, okay? So you still have your y variable here, and then you still have your x variable here, which is what we've been working in this whole time, x, y. But now you're going to start seeing this z variable. And what that means is that now instead of it just being on a straightforward axis where you have an x and y coordinate, okay, now you're going to have another point or another axis called the z-axis, okay? And this is what we call the depth axis, what gives us our depth to 3 dimensions, okay? We're not solving these yet. So what we're going to focus on today is essentially how to write them from whatever the context is that we're working with, okay? So a couple things you need to know. One, you'll have 3 equations, okay? And you'll have 3 variables, hence the reason why it's called a 3x3 system, okay? So a couple things is you have multiple coefficients that you probably need to find. Sometimes you'll have one. You'll have a value on this side, depending on what you're working with. And the most important thing to remember and to know is this. You may or may not always have 3 variables, okay? So when we do these, first thing to know is this: 3 variables, 3 equations, but try to avoid XYZ as much as possible. Now, I know I presented it as XYZ, but when we do this in context, we're looking at variables that match the context itself, okay? Now, if you are comfortable using the XYZ, use XYZ. It's not that big of a deal, but just understand that you will not always see it just XYZ, okay? Now, I'm not going to read this entire piece, okay? You can do that. But I am going to kind of just point out the parts that you're looking for. Now, what I've done here is I've kind of given you the variables already that you want to use for these. And so what that's telling me is that we're looking at the sheets of paper. I'm looking for the boxes of markers and the glue sticks in the particular wording here, okay? So right here, as I read through, the first thing it says is that this person right here, they purchased 3 sheets of paper, 4 boxes of markers, and 5 glue sticks, and he paid $24.40, okay? So that's going to help me write this first particular equation when I do this. If I keep reading, the next person spent $30.40, okay? And she bought 6 sheets of craft paper, 5 boxes of markers, and 2 glue sticks, okay? And then the last person purchased, had a total of $13.40, but he bought 3 sheets of craft paper, 2 boxes of markers, and 1 glue stick, okay? So that's the information we're going to use to actually write the equations. So when I go through and I figure out, okay, so my first equation, I'm going to use it for this person right here, okay? P is my craft, M is my markers, and G is my glue sticks. So the first thing it says is he has 3 sheets of craft paper. So I'm going to write this as 3P. Then he says it has 4 boxes of markers, markers being M. So I'm going to write that as plus 4M. And then the last thing it says is 5 glue sticks, and G is for glue sticks. So I'm going to write plus 5G. G. And the total bill for doing all of this is $24.40. And so what it looks like it's doing, and what I should have done is read the question, but basically what you're doing is you're looking for the cost of each item, okay, which we're not going to focus on right now, but that's kind of where we're going with this. So the next person, and again, I'm actually going to put a J out here so you know who did that, is Maria, okay. She spent $34.40, so we know this is going to be equal to $34.40. 6 sheets of craft paper, 5 boxes of markers, and 2 glue sticks. Okay. And then this last person says, well, they spent $13.40 on their supplies, and they bought 3 sheets of craft paper, 2 boxes of markers, and then 1 glue stick. Now, I don't have to write the one with the G, but I can, and it helps, later on when we actually start solving these. So the next thing you see, it says it's rewriting this XYZ form. Now, what you're going to end up wanting to do is making sure that you have your X's, your Y's, and your Z's in the right order, and that you have your totals in the right order. Because when we start solving these later on, that's going to help tremendously do it. Now, in this case, my P's are in order, my M's are in order, my G's are in order, my totals are in order. So I'm actually okay with the way this is. And so I'm actually not going to change it. That's the correct equation that I'm going to use, that I would use to actually solve it. And that's how you would set up the linear equations that I'm going to use to figure these out later on. Okay. So again, I look at this. And this time it says use XYZ. And again, I'm using XYZ so you can kind of get an idea of how this goes. But it looks like I have a box of pennies. And let's see. Z is quarters. He has 6 times as many dimes as quarters. Total 42 coins in the box. 10 less pennies than dimes. Okay, so here's what I'm going to do with this. I'm going to separate this into my different parts. One of the parts I know is going to be the fact that he has 6 times as many dimes as quarters. So that'll be one of my equations already. The next thing I also know is that there's a total of 42 coins in the box. And then the last thing I know is that he has 10 less pennies than dimes. Okay. So I'm going to start with this first one in green where he has a total coins in the box. This is a pretty typical equation where I know a total is something and I want to be able to write an equation of this. So here's basically what it's saying. It says that if I take the number of pennies that I have, we'll call that X, and I add the number of dimes, we'll call that Y, and I add the number of quarters that I have, we'll call that Z, the total number of all 3 of these coins, whatever it is, is going to sum up to 42. Okay, and that's a very, very, very typical equation that you would ever have to write for that. Okay. So the next thing I'm going to look at is this right here where it says he has 6 times as many dimes as quarters. Well, we know we have dimes as Y. I'm going to write it up here, and we know we have quarters. So basically what it's saying is this. If I had 5 quarters, then I would have 30 dimes. And I don't know why I wrote a Q, truthfully. I meant to write that as Z. If I had 1 quarter, I would have 6 dimes. Okay. So what you're doing is every time you take this number, you're multiplying it by 6 to get that number. And so when I write my equation, whatever Z is, I multiply it by 6 to get that number. So my second equation is going to essentially be Y equals 6Z. Okay. And then the last one is 10 less pennies than dimes. And again, same situation. If I have dimes and pennies, right? So let's just say I had 20 dimes. That means I would have 10 pennies. Okay. If I had 30 dimes, that means I have 20 pennies. And I could write this different ways. I could write this where, this would be y minus 10 gives me this, or I could write this where x plus 10 gives me this. Okay. Either way would work to do this. I'm going to choose this one right here, where I know the number of dimes I have would be the number of pennies plus 10 more. Okay. And sometimes that's one of the more complex things to be able to do, is to interpret this to this. But if you kind of just draw yourself little diagrams, it kind of helps recognize and see, what I'm doing here. If I had written it with y minus 10 equals x, I would come out with the same answer I'm going to look for anyway. But here's kind of the important part. I want to rewrite this in an xyz equals 0 format. And here's what happens. So the first one here, xyz is equal to 42. Okay. I'm okay with that the way it is. And really, truthfully, this is not necessarily 0, but I'm going to leave that the way it is, and I'm not going to mess with that one. Okay. On this one, however, I have a y and I have a z in this spot. So I want to make sure that when I write this, I write it where my x and my z are on the same side. I'm sorry, my y and my z are on the same side. Well, in order to do that, I have to move this 6z to the other side. And when I do that, I get that it's y minus 6z, and then now it's equal to 0 on the right side. Okay. Here, same thing. I want to make sure that my x and my y are on the same side. Here, my x is not on the same side. So if I subtract x from this side, I get that it's negative x plus y is equal to 10. Now, notice the way when I wrote this, how I wrote my x's in the same spots, my y's in the same spots, and my z's in the same spot, and then my totals in the same spot. Okay. I want to make sure it looks like this to match up with this, so that when I'm able to solve these later on, I have this correct in the correct format. So this is what I would be looking for in terms of setting up your equations. Okay. Tables are actually a little bit easier to work with, because a lot of times tables are already set up for you. You just have to know how to rewrite it. So in this case here, C is Canada, U is for United States, and B is for Brazil. I'm going to read it real fast, make sure I'm not going to miss anything. And then the question pretty much would be, what is the cost per minute for each place? Which I realize it's not what it says here, but that's pretty much what the question would be, is what is the cost per minute for each particular place? Okay. So if I write this, the way you look at this is this. For the first equation, if I take the month of September, however much time I talk with Canada, let me circle this, with Canada, with the US, and with Brazil, has to add up to $252. If I take my October bill, 70 minutes with 100 minutes to US, to 120 minutes to Brazil, has to give me 184. And then again, if I do 50 minutes with 110 minutes, 150 has to give me 206 in the bill. And I do that to make sure that I add these up correctly. The most common mistake a lot of times is to do this vertically versus horizontally. And so when I write my first equation for September, it would look something like this. Kind of like that. See? Horizontally straight across. If I do my October bill, same kind of concept. Kind of like that. And if I do my November bill, okay. And the most important part is, am I written this correctly, where this is C, U, and B, or my, X, Y, Z? And it is, so I'm not going to rewrite anything because this is in the correct format already. All right. So look at this one, try this one. I'll be back in a second to see if you get what I get. And yeah, we'll go from there. All right, so here's what I got. Okay, there's the original equations. There's my reformatted where you have the C's, the U's, and the M's together. Okay, and my totals. So again, money with money with money with money. It's excuse me. It's making sure that you match those up like you're supposed to. Okay. The other thing also I'm gonna tell you about money. You have to be careful with it because this is 28 cents. But down here I wrote 0.28 because that's 28 cents. How you write 28 cents. Twice as long to the Mexico as the U.S. Again, if you did it 1 minute in the U.S., that's 2 minutes in Mexico, 2 minutes, 4 minutes. So that looks like something like M equals 2U. Okay, so that's what I wrote here. And then total number of minutes spent with Canada and Mexico is 122. So C plus M is equal to 122. So again, when I rewrote it over here, the first one didn't really change. The second one, I want to make sure that my U's match up. So this is subtract 2U to this side. So I get the 2U right there. And I went ahead and separated my C and my M, even though I know it looks kind of funny. But that's, what it would look like to set it up. Now, I will tell you this. If it really helps you with placeholders, you could essentially put zeros there too if you really wanted to, but it's not necessary. Okay. All right. Last one, try it, see what you get, and then I'll be back in a second. All right, folks, this was a little bit, it was a little bit straightforward. Tables I always find to be a lot straightforward, so long as there's no vertical component to this. But there they are down here. Let me see if you can see that. I just kind of realized it kind of looks kind of funny. But 4, 4, 6, and 21. B's match up, C's match up, P's match up. So there it is. So that's how you set up a system of equations. And the next thing you would see after this would be to solve them. But again, we're not doing that today with these. So there you are. Have fun. And we'll see y'all around.